Hello and welcome to my first attempt at making a coding tutorial video. Just to be original, I'm doing a coding tutorial video on Minecraft. Now, I am by no means an expert. I pretty much learn everything I've learned from these kinds of videos that I'm hoping to make here. I'm not going to claim that my code is any more elegant or more efficient or better in any way than any of the more talented people out there. What I'm hoping to do is make the code in such a way that is as easy as possible to follow along if you don't quite understand what's going on to begin with, because that part I do understand, because that was me and still is me in a lot of cases. But in this particular subject, I think I've managed to get to a point where I can at least help some people. So I'm not going to waste any time explaining what Minecraft is. If you're here, I'm assuming you know what Minecraft is. So you may be wondering why it's such a big deal to make something like Minecraft. You could just use the built-in Unity primitive thing. There we have a cube. We could quite easily duplicate that cube, move it next. It would help if the first cube was in a 0 position. Move them next to each other and then programmatically put them all over the place, and we've got lots of cubes. Now, the reason for that is, there's two reasons. One, it is very expensive because in terms of resources, because each of these cubes is in its own game object. It's got its own collider, it's got its own cube mesh, its own mesh renderer, it's got its own transform. It's very expensive to put all these objects on screen. And then the other problem is that Unity does have an actual limitation. It can only draw so many game objects. It can only have so many game objects in existence at once. It is a high number. It can get quite a lot of game objects on screen, but you're gonna hit that in a game like Minecraft because there are a lot of cubes. So we're not going to do that. The easier way is to actually draw what we call chunks. I imagine most people who know what Minecraft is know what chunks are. And instead of drawing each individual cube, you just draw the actual mesh of the outside of that chunk. So if you have 10 cubes all along in a flat surface like a floor, you don't need to draw anything under that floor because you can't see it until you start digging. We'll get to that part. So I've made a little reference tool just to help us understand. This is a voxel, or a Minecraft voxel, and as you can see, we have 8 corners. These are 8 corners of the cube. This is essentially the only location data that we need, is to know where these 8 corners are. So what we're going to do, if we go back into Unity, and we'll make ourselves a nice little scripts folder because we want to keep everything nice and neat, and we'll spell scripts right because that's always a good start. And what we're going to do is we're going to make a lookup table that stores all of this information, where these eight vertices are. You can do this programmatically. You can do it in for loops. You can use maths to work out where everything needs to be. I'm not saying this is in any way more efficient. It might actually be more efficient. I'm not sure. It's definitely not more elegant. But like I say, I'm trying to do this in a way that's easier to follow rather than any particular spectacular way of doing it. So the way we're going to do this is we're going to create ourselves a static class. We'll call this voxel data. We'll open up this, and we want it to be a static class because the whole point of this, if it ever actually opens, the whole point of this class is that it's just going to store data that we need. It's not going to do anything else. So it's not going to be attached to anything. It's not going to be edited. It's just going to store data. So we get rid of mono behavior because we're not putting it on anything. Public, obviously. Static, so that we can access it from anywhere. And then inside, we're going to make a static array. So this wants to be public static. We're going to make it read-only because we don't want it getting edited halfway through the game, because that will cause all sorts of problems if the cubes start changing size and things in the middle of a game. Because in theory in Minecraft, the world is constantly being generated. Unless you have a set size and you generate everything at once, the world is constantly being generated. So if you start changing the fundamental values of a voxel or a chunk or anything partway through the game, you're going to get all kinds of weird stuff happening. So we're going to call this voxel verts. Doesn't really matter what you call it, I suppose, but it just helps to call it something that makes a bit of sense. Now, we know, just go back here, we know how many verts there are. Each one of these red dots, red spheres, represents a vert. So we know that there are 8 verts. there's always going to be 8 verts on a cube. Now, as we get later on and we start drawing things like stairs, for example, that's going to change, but we'll worry about that later. For now, we know that all of our blocks have got 8 verts, so we don't need to worry about what the size is because we can set it. So we're going to set it to 8 because 8 verts, that's where it is. And then inside of here, we're going to put 8 vector 3s. And these represent the locations of those verts. So our first vector 3 is 0, 0, 0. Luckily, I've added a little feature to this so I can show this. So we'll go back to the front or the back. I'm not quite sure which way it's oriented. So we have 0, 0, 0 here. And then 0 next to it, next to the actual coordinate, is the index that it's going to be in this array. So here, this is the first one in the index in the array, so that is index 0. As you can see, 1, 0, 0 has got index 1, so that's going to be the next one in the array, and then 3, 0, 1, 0, 2, 1, 1, 0. This order that you put these in isn't necessarily important. It's not important that you do it the same way that I've done it, but it is important for later on. The order 1, 0, 1, 0. 1, 1, 1. And then finally 0, 1, 1. So there we have all of our vertices in an array format, all of these coordinates. So each one of these represents one of these. Now, the way Unity or any 3D thing draws a 3D object is by triangles. So each one of these vertices, 3 of them together can make up a triangle. So if I click this one, and this one, we see we get a triangle between these. This is how it's all polygonal 3D meshes are made. It's just a collection of these triangles, and obviously the more of these red dots you have, the more detail you can have. We're just drawing a block, so we don't really need to worry about that sort of thing. But obviously to draw the block, we'd have this, to draw a face of a block, we would have this triangle, and then we would have this triangle, and together that would make the face of a block. So I've only coded this so that I can draw one triangle at a time, so I can't show you the whole face. But you get the idea. Now, the important thing about this is that the direction that the triangle is drawn in, so right now I'm going 1, 2, 3, is very important, because clockwise means forward, or if you do it clockwise, the way your face, as you're looking at it, that's where it will draw the face. If I spin round to the back here, you'll see it disappears, because the back side of a triangle is not rendered. You would have to do some fancy stuff to make it render both sides of a triangle. So if I were to draw that triangle backwards, we can't see it. But if I spin round here, there it is. So all the triangles, you have to add them in a clockwise order to the direction that you want them to actually face. So if I go up here and add it backwards, you can't see anything. But if I go the same 3 dots that way, we get a triangle. So the way that Unity knows which triangles to add is we have 2 arrays. We have a vertices array, which just stores these values here, stores the location data of the vertices, and then it has a triangle array, and the triangle array is just an int array. And what the int array does is it references in the, not this array, this is just a lookup table, but in the actual vertices array that we're going to put these values into, it references the index that a particular vertices will be in. So if we put this, if this vertices here ends up in, I don't know, number 24 in the vertex array, then we need to reference number 24 in the triangle array when we want to call that vertices. So the way we're going to do it, we're going to use another lookup table. We go public static read only again, because again we don't want this to change. This is just for reference. It's not actually going to do anything in the game. We'll call this one Voxel tries, new int, and again we know the values, because if you look in here, we know that each face is made up. That's 1, 2, 3, and then 1, 2, 3. I've just drawn that backwards, but you get the idea. We know that each face is made up of 6 triangles. 6 triangle references, sorry. 1, 2, 3, 1, 2, 3. So we know that each one of these faces is going to need 6 triangles, and we know that there are 6 faces: the top, bottom, back, left, right, forward, all that sort of thing. So we want it to be 6 by 6 because we've got 1 for each face and 6 triangles on each face. However, for now, we're just going to draw. Oops, sorry. In an equal signs in there. For now, we're just going to do 1 face. So we need to set that to 1 because otherwise it'll come up with an error because I haven't put the rest of the faces in. And we'll do the top face. So 3, 7, 2, 2, 7, 6. And again, I'm not doing this from memory. I do have this written down on a bit of paper. So that is currently the only face in there. Just put that so we can keep track of that. That's currently the only face in there, so we don't need to worry about what reference. We're just going to be calling index 0, and then what we will do is we will loop through these, each one, and then for each one of these triangles we will add the corresponding vector 3 from here into the vertex array. So the first one is 3, so that's 0, 1, 2. This would be the first one that's being added. And then the next one is 7, so then it would add 7, and then 2, so then it would add 2. Remember, the first item in an array is 0. Right, so we'll save this and back into Unity, not that reference thing. And we need another script. This one will be a regular mono behavior. We're going to call it chunk. We'll get more into chunks and what they do later. So in here, get rid of the update for now. We're not going to be needing that. We need a reference to a mesh renderer and a mesh filter. So we'll just go back into Unity, and I'm going to create a game object, create empty. We'll just call this chunk for now. And we're going to add a mesh filter and a mesh renderer, and then we'll drag our script onto here and then link up the mesh filter and the mesh renderer. So the mesh filter, basically all it does is it stores the data for the actual mesh, the vertex locations, the triangles, all that kind of thing is all stored in the mesh filter. When there is a mesh there, this object here will have a mesh in it. I could give it one now, but obviously we're going to be creating our own, so we don't want to put that in there. And then the mesh renderer stores, as it looks like, your materials, like so your textures, all that kind of thing, your lighting. None of that's important for now. So now that we've got that, we'll go back in here. We're going to need to keep track of the current triangle that we're on, for a reason that'll be easier to explain once I've written a bit more code. But let's just get this here, and then what we need is an array of vertices that we're going to store for the mesh. I'm going to use a list. Like I said, this is not, the way I'm doing it is not necessarily the most efficient. I'm almost certain that a list is not the most efficient way to do this, but it will work, and it's a little bit easier to follow along what's going on. So we're going to create a list of vector 3s. We'll call this vertices equals new list vector 3. And then we need another list of triangles, so of ints, sorry, for our triangles. Okay, now we need a for loop, and what we're doing here is we're looping through whichever one of these. At the minute there's only one, so there's no question which one we're actually going to be looping through, but whichever one of these we're currently on, we need to loop through each int in that array. So we know at the minute, obviously this will get a little bit more complicated further down the line, but at the minute we know that there are 6 in there. So we don't need to worry about how long the array is because we know it's going to be 6. So I is less than 6. Now in here, we're just going to add to the array, so we're using this nice and simple command, vertices.add. We call our Voxel data class. It's static, so we can get at that from anywhere. Voxel verts, No, sorry, that's wrong. Voxel, no. So in here, we need to get the current triangle that we're on. So what we'll do is we will make a new int and we'll call it current triangle. And you know what? We'll call it triangle index. And we'll call this one vertex index because that's probably a bit more accurate. Right, so we'll call this one triangle index. Now this is going to equal, we'll get a reference to our Voxel data class, Voxel tries, and then for now we've only got one, so we don't need to worry about which. So we don't need to worry about which of these arrays, because right now there is only one array. So we reference 0, and then this one wants to be I, the current iteration of the loop. So now we have that. We just go into vertices dot add. Nice handy command, makes it a lot easier than trying to work out where we are in an array, because this just adds to the end of that list. Like I say, not particularly efficient, but for what we're doing, it should work. Another reference to the Voxel data class. This time we're going for the Voxel verts array, and we're adding whatever the current triangle says. So what this line here is doing is, well, this one here is pulling a number out of here, and then this is using that number to add one of these vertices. So if the number is 7, then it's going to add this one. So this is how we populate our vertices list. Now we need to populate a triangles list. Now, unfortunately, we can't just use any of this data because this data these numbers here only correspond to this. We're creating a new list here, a new array. So we need to keep track of what triangle we're on. So the way we're going to do this is this vertex index that I've created up here that I haven't explained yet. We're just going to we're just going to use that to add to the triangles, and all we're going to do is add whatever the current vertex index is, and then after we've done that, we will increment vertex index. So every time we've added a vertex, we add the current vertex index. It starts off at 0, we add 1, and then it increments to 1, and then the next one will be 1, and so every single triangle is added in the right order. And this determines the order. We know that it's going to be in the right order for... we know it's going to be in the right order because that's the way we've done it in that array. So like I said, the order that we do these numbers is important. And it's also... For reasons that'll be a bit more apparent when we get to the texturing part, the order that we do them needs to be the same on each face. So if I start bottom left, go straight up and across there, if that's my first triangle, then when I do the top face, my first triangle again needs to be whatever the bottom left is. Like, let's just say that I want it to face this way, needs to go up and across in the exact same way because of the way that we're going to do the texturing. Like I said, there may be other ways to do it. It just makes it a bit easier to explain, I think. Let me know in the comments if you think I'm wrong. So if I decide, or I have decided, to start bottom left, go straight up and then across, then I need to do that on every face so that the texturing, the way I'm going to do the texturing will work out. So we'll go back in here. We'll go back in here, sorry. Save that. Now, this will loop through the current triangle, which is the current face, which is the only face we've got at the minute, and it will add the necessary vertices and the triangles to the array. And then what we need to do is create a mesh that we can then put that detail in. So we'll get a new mesh like that. There's no capital there. And then we need to add our vertices list into the mesh's vertices array. Fortunately, there is a nice little handy built-in function on the list to just create an array, and that's vertices.toArray. Same again with the triangles. And then we need to recalculate the normals. I'll explain this a little bit better in a second. So we do this by recalculate normals. Now, the recalculate normals thing if you don't already know, each one of these vertices has a direction that it is facing. So this is so that the Unity can render the light and other things accurately. You start messing with the normals, you get all sorts of weird artifacts and things not looking quite right. We're drawing a cube, so it's not really important. Every face, like these 4 vertices here, face straight upwards. These 4 here face this way. And yes, there are, I know it looks like we only need 8 vertices, but there are actually, each face has its own 4 vertices. So each vertices has actually got 3 vertices in the same position. This is necessary to draw an actual cube as opposed to drawing a sort of smooth blob. Because Unity will attempt to smooth between vertices, so you won't get this nice hard edge if you just share all the vertices, even though it feels like it should be more efficient, and it probably is more efficient, but visually, to get this nice crisp edge of your cube, you need to have a vertices for every edge. So this face can't share a vertices with this face, otherwise this edge would be all smoothed over. And I've completely forgotten why I was saying that. Alright, for the recalculate normals. So because we're just drawing straight faces, because the direction of these vertices is just going to be straight up, and for these ones it's going to be straightforward, we don't need to do anything complicated, so recalculate normals, the built-in function, is perfectly capable of doing this. And then, when we finally finished doing that, we call our mesh filter mesh, and we set our new mesh to that. So now, in theory, if I press play, we should get a luminous purple square, which you can't see because of the position of the camera, but there it is. It's luminous purple because there is currently no texture or material data. So we'll just quickly fix that for now, temporarily. The way we do this, we need one more list. This is a list of vector 2s. And I'll explain this a bit better when we actually do the texturing, but for now, I'm just going to do something just to get rid of that horrible purple colour. So we're going to call this one UVs equals new list vector 2, and then down here all we're going to do for the time being is just add vector 2.0, and then down here mesh.uv equals uvs.to array, and try not to press all sorts of random keys with my fat fingers. In theory that should get rid of the, it should get rid, but it hasn't. Oh right, sorry. Yes, so we do actually need to give it a material, so we'll create a materials folder, and then we will create a material that we will just call voxels for now. That'll do, and get rid of the smoothness, make it not shiny because that's horrible. And then if we go into our chunk and we drop down this little menu here, we have a materials thing. Just drag this into there, and in theory that should fix that horrible purple. There we go. So now we have a nice white square. It is drawn a 1 by 1 square, should be 1 off the ground, and now we have our top face. So if we go back in to our code and we go back into voxel data, we can, now that we know how that works, let's add the rest of these faces. So again, I've got all this written down, and again, it is important what order you do it. It does make a difference what order you do it in. I'm not saying that you couldn't change this order if for some reason you felt that it would benefit your code, but the order is important. You need to keep track of the order that you're doing the code in. Of course, it would help if you were using the right symbols. So this is the back face. This is the front face. And that is all of our faces. So now that we have all of our faces, we should be able to use this data to change our code in here a bit and draw a full cube. So what we need to do now is we need to create a second loop. So we'll just do this one as we'll call it P. For int P equals 0, P is less than, and again we know that this is 6 because when I change this here I will have set it as 6. So so we don't need to worry about what the specific length of the array is because we set the length. So we'll set that to 6, P++, and then enclose all that. Right, so now we have 2 loops, and then all we're going to do here is instead of calling the 0 index, the first face, every time, we're going to call whatever P is. So all that means is that it's going to loop through each one of these, and then for each one of these it's going to loop through each one of these, and then it's going to do what we've already established it's doing. So if I go back into Unity, we should have a full cube this time. Yep. There we go. For each face, it's looping through, and it's drawing the triangles to create each face, which put together makes a full cube, and that's basically all the voxel is. Obviously there's more involved in drawing the full chunk. So the last thing I want to do for this video is get the texturing working. So I've got a little picture somewhere that I've lost. There it is. So to understand how textures work, basically each one of the UV vector 2's is a coordinate on the actual texture. So the textures work 0, 0 is bottom left, 0, 1 is top left, 1, 1 top right, etc. And your dead center would be 0.5, 0.5. It's a normalized value for the texture. So regardless of what size the texture is, 0 is the bottom left and 1, 1 is the top right. So if it was 100, then 0.9, if it was 100 pixels wide, 0.9 would be 90 pixels into the texture. And the way that Unity draws these textures on your actual model is that you assign a match. These vector, where are we at? These vector 2's here correspond directly to the vector 3's in here. So whatever index 1 is of this vector 3, index 1 of this vector 2 will correspond to it. And what that means is that if this one has got a UV, or if the matching UV vector for this one is at 0, 0, and then the matching UV vector for this one is at 0, 1, and then the matching UV vector for the other side of the triangle is at 1, 0, then that triangle will show the bottom half, or this diagonal half of this texture. This texture is the one I'm going to use just for setting up, by the way. So with that in mind, go back into Unity. That's not Unity. Go back into Unity, and we're going to create a new folder just for textures. Again, just keep everything nice and organized. And then I'm going to drag my texture. I'm going to attempt to drag my texture into there. Make sure everything's set right. This texture is only 16 pixels. We want it on clamp because when you have it on repeat, you can kind of get a weird little bleed edge. It shouldn't be a problem with this texture because it's got a black border, but when you have it on repeat, you can get sort of a bleed over effect around the edges. And each face that we draw is going to want its own contained texture, so we don't want anything bleeding over from the edges. And we want point mode because we're doing Minecraft, so we don't want everything to be, we don't want Unity attempting to smooth the texture out. So we'll apply that. Now, in our materials, sorry, Unity's running a little bit slow at the minute. In our materials, we go to Voxel, go to our Voxels material, and we go up to here, and we want to set this as the texture. So now, whatever UV information we use on our actual mesh will be referencing this texture. So let's get started in actually setting that. And the way we're going to do this is we're going to use another lookup table. Now, if you remember, I said that I needed to keep the order that the triangles were done for each face the same. So the way I've been doing it is I've been going bottom left, top left, bottom right, and then I think, pretty sure I've been going bottom right, top left, top right, whatever the order is. It's the same on every face. And what that allows me to do is it allows me to just have a lookup table of vector 2s, which we're going to set up the exact same way as the other ones. And then I can just call this without having to worry about what position we are in or anything like that, because everything's added in the same order. So it'll be easy to explain once I've actually done it. So we'll just set this up for now. Voxel UVs equals new vector 2 6 again, because we know that there is only 6 vertices in a six triangle indexes in a face, and we only need to store information for one face, and then we can use it for each different face. So each of our faces, the first vertex that gets added is the bottom left. So the bottom left of the actual face wants to be the bottom left of the texture. And then the next one, so if we look at this one, this is the back face, we go 0, 3. So we're going 0 as our first one, and then 3 is our second one. So this one's 0, 0, that's 0, 0 down here. The next one's 0, 1. So we want to add 0, 1 next. So we'll just copy that, because I'm lazy. And then 0, 1. And then if we look again, the next one is 1. So 1 in here is this one. So that's the bottom right of our texture, which, as you can see, is 1, 0. And so on. Like I say, I've written all this down so I don't forget it. Hopefully that's enough for you to understand what's going on. I'll just add the rest of the numbers, rest of the vectors. So we've got a first triangle, and then from there, 1, 0, 0, 1, and finally 1, 1. Semicolon on the end of there. So this is our lookup table for voxel UVs. And then what this allows us to do, instead of just adding a vector 2.0, we can add voxel data, voxel UVs, and then the current triangle index that we're using. And that should give us oh, let's just see what I've done wrong here. And oh, right, okay. I'm sorry if anyone's been screaming at their monitor or whatever. Unity thinks I've been trying to put in a vector 3. So we'll try that again when that's finished. Has that got rid of everything? Yep. Right, so if I press play now, we should have a textured voxel. There we go. And all that's doing is for each face, it's referencing our one texture that we've got here. Obviously, things get a little bit more complicated when you want different textures on the voxel, because you have to work out the position of each texture within the overall texture. I don't know if you've ever seen a Minecraft texture pack, but it's basically one big picture of lots of little 16 by 16 pictures. You need to work out where in that picture each vertices needs to reference. So it's easy when it's 0 and 1, 0 and 0, 1 and 1, 1. That's easy enough. The problem comes when you've got 16 of these and you need to divide it up. I mean, it's not that big a problem, but it's more complicated than this. So that is where I'm going to end this video. We've got one nice little voxel on the screen. In the next video, we're going to turn it into a chunk full of voxels, Minecraft voxels, that is. As you can see, it's drawn it all the way around, and hopefully we will get a nice chunk going next time. Any feedback will be appreciated. Like I say, this is just a bit of an experiment for me, but for now, have fun.